Information Retrieval and Online Disinformation Detection by Vanessa Gregoire, Yan Bin Lin, and Michael Lopez Cruz. Table of Contents. Introduction. The rapid rise of social networking platform has not only yielded a vast increase in information accessibility, but has also accelerated the spread of hate speech and fake news. Thus, the effect of those inappropriate speeches have been growing, sometimes extending to the offline world and threatening public safety. Given the mass amount of web content, automatic harmful information detection is a practical NLP problem useful to all online content providers in order to reduce the human time and effort to detect and prevent the spread of incorrect thoughts. Misinformation, otherwise known as satire, is false information, but it is not created with the intention to harm. Disinformation, otherwise known as fake news, is deliberately created to deceive others, whereas malinformation has the intent to cause harm, otherwise known as hate speech. Hate speech detection. What is hate speech? Hate speech has been defined as the act of communicating strong negativity towards a person or group because of particular characteristics. These characteristics can be many things, such as race, weight, sexual orientation, gender, or ethnicity. Hate speech can vary with time, constantly being defined by the current generation and being changed online and in person. Social media companies are attempting to detect hate speech and offensive material at the many requests of users who want this act to be punished and taken down. Often spending millions of dollars on counteracting hate speech, detecting it can be hard as hate speech is unique and can be categorized and said in many ways, causing trouble for the companies to keep up. How is hate speech detected? Social media companies often use manual detection practices to determine if certain things are hate speech or not. Yet this is not an effective way to detect the many messages that are on their platform. Recently, social media companies have turned to automation to pick out certain words and phrases and determine it to be hate speech if reported to them. But automation can lead to errors and false positives and negatives. Deep NLP for hate speech detection. Natural language processing, a field of computer science focused on detecting, understanding, and processing language, can be used to determine hate speech a lot easier than doing it manually. By doing it in this way, the process of detecting hate speech can be simplified for larger group sets, just requiring a training set to start learning how to detect things on its own. Parsing. There are two methods in which parsing can occur: bag of words or term frequency inverse document frequency. Bag of words methods treats the text less like a long passage and more like separate words individually. It will disregard grammar and punctuation, focusing solely on the words themselves, checking how frequently they are used in documents. Term frequency inverse document frequency instead takes the words and gives them a certain weight, organizing them into terms of importance, thus removing words that does not hold any importance for the search. In this method, it will have a focus on words that can be used in usually hateful ways, detecting if the text has a strong leaning towards hatefulness. Training. To help aid in finding what to mark down as hate speech, having a dataset is necessary. Datasets need to be used to help aid the program in seeing what is defined as hate speech or not. By giving it this basis, the accuracy can be more and more fine-tuned. For instance, Burrell uses a dataset from another article who gathered it from a white supremacy website. Another dataset mentioned by Burrell is by Tom Davidson, consisting of around 55,000 sets. This allowed for an extensively long set of hate speech datasets and aided in defining and specifying what is and isn't hate speech. Social media outlets can use their own database and find examples of what they determine as hate speech on their platform as a basis for hate speech. From there, everything else can be set up for hate speech detection. Bag of words. Bag of words is the best system for smaller testing sets. With the system, finding hate speech depends on the frequency certain words show up and if certain words are considered hate speech or not. To keep track of the words, a vector can be created, marking down 1 for each time a certain word appears. This method keeps track of words and makes identifying hate speech a lot easier. On this slide, you can see an example output after running a hate speech detection test using the back of words method. Term frequency inverse document frequency. The term frequency inverse document frequency method is the best for more ambiguous testing sets. Because certain words can be used in both harmful and non-harmful ways, and slang is continuously changing, TF-IDF is used for finding more of the hidden intention in words, setting weights of importance each of them have, and verifying if they are hate speech based on overall weight. If you notice on this slide, the table above depicts the outcome after running a hate speech detection test using the TF-IDF method, showing that the accuracy using this method is a little higher than bag of words, meaning that taking into consideration the greater meaning in these words helps define whether the intention was hate speech or not. The future for hate speech detection. The future of hate speech detection consists of mainly trying to adapt and change with the times. New words and phrases are being said constantly, and because of that, hate speech is continuously changing, making it easier and easier for hate speech detection to grow obsolete. We need to develop a way to easily update that, possibly through machine learning, so it can learn how certain words are used and update itself in hate speech. Otherwise, manually, people need to update the word list and instances consistently to make sure hate speech detection is up to date. As well, people are able to mask hate speech through different spellings and allusions to certain words. This would need manual detection because evasion for hate speech by automated systems is always going to occur. With these ideas in mind, hate speech detection must always be able to catch up because social media and the users on it will always be one step ahead.
Here we will discuss fake news detection. A great amount of fake news, hoaxes, hurtful comments, inaccurate reviews, and offensive content is published and propagated every day in social media, which can lead to a lot of negative consequences for the society. For example, in the political domain, fake news stories have been criticized as having an impact on the results of elections. According to UN experts, hate speech has exacerbated social and racial tensions, inciting attacks with deadly consequences around the world. As the internet community and the speed of the spread of information are growing rapidly, automated fake news detection on internet content has gained interest in the artificial intelligence research community. The task of fake news detection has been studied from various perspectives with the development in sub-areas of computer science such as machine learning, data mining, and NLP. In this survey, we are focused on automatic fake news detection from the perspective of NLP. We will introduce the technical challenges in fake news detection and how researchers define different tasks and formulate ML solutions to tackle this problem. We will also discuss the pros and cons of each task. In the end of the second part, we will also discuss a guideline for future research in this direction. Related problems such as fact-checking is the task of assessing the truthfulness of claims made by public figures such as politicians, pundits, etc. Rumor must contain information that can be verified rather than subjective opinions or feelings. Stance detection is the task of accessing what side of debate an author is on from text. Sentiment analysis is the task of extracting emotions such as customers' favorable or unfavorable impression of a restaurant. Especially we focus on fake news detection of text content. The input can be text ranging from short statements or entire articles. The general goal of fake news detection is to identify fake news defined as the false stories that appear to be news, including rumor judges as information that can be verified in rumor detection. There are different types of labeling or scoring strategies for fake news detection. In most studies, fake news detection is formulated as a classification or regression problem, but the classification is more frequently used. The most common way is to formulate the fake news detection as a binary classification problem, but there are some changes. Categorizing all news into two classes is difficult because there are cases where the news is partially real and partially fake. To address this problem, adding additional classes is common practice. One of the conditions for fake news classifier to achieve good performance is to have sufficient label data, meaning a category for the news which is neither complete real nor complete fake, or more than 2 degrees of truthfulness are set as additional classes. However, to obtain reliable labels requires a lot of time and labor. Therefore, semi-week or weekly supervised and unsupervised measures are proposed. Fake news detection can also be formulated as a regression task, where the output is numeric scores of truthfulness. Usually, evaluation is done by calculating the difference between the predicted scores and the non-truth scores, or using Pearson or Spearman correlations. However, since the available dataset have discrete non-truth scores, the challenge here is how to convert the discrete label to numeric scores. Public fake news dataset can be categorized into 3 categories: claims, entire articles, social networking service data. Table 1 shows a summary of various fake news detection related datasets. Here introduced methods. Firstly is pre-processing. Pre-processing usually includes tokenization, stemming, and generalization or weighting words. The majority of existing research uses supervised methods, while semi-supervised or unsupervised methods are less commonly used. The supervised machine learning methods include support vector machine and naive Bayes classifier are frequently used classification models. Logistic regression and decision trees such as Retrieval forest classifier are also used occasionally. Recurrent neural network is very popular in natural language processing, especially long short-term memory. CNN is also used for extracting features with a variety of metadata. There are another 2 methods also used for fake news detection. There are some critics of common methods. First, handcrafted features are essential in non-neural network approaches, but can be replaced by neural networks. Second, the attention mechanism can help improve the performance of fake news detection models. Third, metadata and additional information can be utilized to improve the robustness and to suppress the noise of a single textual claim or article, but should be carefully used. Content-based approaches should be developed more in the future.
Hey everyone, my name is Michael Lopez and I'll be going over sentiment and emotion analysis for hate speech detection. So first we'll be going over what is sentiment analysis. So sentiment analysis is the process of detecting if a text is either positive or negative. And in this case, sentiment being like the general emotion that the text brings to the reader. So currently sentiment analysis can be done using NLP, machine learning, or other data analysis techniques. So going over some of the current work being done with sentiment analysis and hate speech detection is, for example, the National Cohesion and Integration Commission. So what they're doing is they're using web crawlers to collect data from different social media platforms, and then after this data is collected, a actual person goes and analyzes this data and then labels it as either hate speech or non-hate speech. And one thing that the research department is doing that is really good for the machine learning and data retrieval community is that they provide the keywords for the most frequently being used terms in hate speech text. So this is really good because when somebody wants to implement a machine learning model that for detecting hate speech, they can reference these keywords that they provide and able to weigh them properly and gives a good head start for this model that's being created. So why is sentiment analysis important? One of the reasons is because hate messages are being used more and more online. One of the factors that leads to this is because users can post anonymously. So this leads to more confidence and also makes the user feel like they don't have to deal with the consequences of whatever they post. Another reason it's important is because more and more people are using social media. So pretty much almost anyone that has access to the internet is on some type of social media and can come in contact with hate speech. So in 2018, a study was ran to determine how many teenagers were being affected by hate speech in social media. So the results were that around 50% often or sometimes encountered hate speech, and about 11 to 14%, just averaging it out, encountered hate speech oftenly. It's a pretty big number, so it's important that this issue is tackled. So for our presentation, we'll be going over a case where sentiment analysis was being used with Twitter to be able to detect hate tweets. So document classification was done using NLP, and the data was pre-processed using bag of words and TF-IDF. The goal of this case is to detect and classify tweets into two categories, if it's either hate speech or non-hate speech. So going over the details of the approach, you can see that the data was divided into the tweet, which is the actual text content, the label, which is how we're classifying the text of either hate speech or non-hate, and the ID, which is just used to as a serial number to find the tweet. One thing they ran into was that there was a data imbalance. So about only 7% of tweets are hate tweets. So this can lead to an incorrect weighting when actually running the training for the model. So SMOTE was used to correct this data imbalance. And for the pre-processing, it was a pretty standard pre-processing. Stop words were removed, special characters removed, slang words were converted to the actual words that they mean, stemming, and lemmatization, which is grouping different ways a word is said into a single word. So how is sentiment analysis used in this specific project? So the words are categorized as positive and negative, and these also have a specific value that goes with them. A word cloud and bar graph was also created to visualize how these positive and negative words are being used. So here's the word cloud for the positive tweets. You can see that the most prominent ones are, in this case, love, smile, day, life. And this is just done to visualize the importance of certain words when classifying these tweets. And here's the bar graph. So as you can see, love is the most counted word. Next is positive, thankful, and smile, healthy are also words that are commonly used for positive tweets. So here we have the word cloud for negative tweets. So you can see some of the most prominent words such as woman, white, black, Trump. So just for background, the study was ran in 2019, which is when the campaigns were being ran. So that's why Trump was a divisive word. And some of these other words are prominent because they can be used to classify a tweet as either racist, sexist, homophobic. Here we have the results using bag of words. Logistic regression was the best algorithm to use with an accuracy of about 88%, which is good, but it also has room for improvement. Here's a bar graph for the results for a bag of words, just so you can visually compare them. And here are the results with TF-IDF. And the best algorithm in this case was also logistic regression, but the accuracy was 89% versus 88 with bag of words. And here's the bar graph for TF-IDF. And as you can see, the accuracy and recall are the best in this case with logistic regression. So some of the challenges that they ran into in this project uh, was the changing of attitudes towards certain topics over time and also historical context. So, for example, there's a text that says, "The merciless Indian savages whose known rule of warfare," and it continues. So this text was classified as hate speech, but this tweet was actually a quote from the Constitution, and it labeled it as hate speech because of the merciless, and it also refers to the Indian as savages, which is categorizing a certain group of people as something that is not positive. But in this case, it was actually just a quote from a text, which was the Constitution. Another example is the Nazi organization was great. Without context, this seems like a tweet that supports the Nazi organization as and the ideas behind it, but it actually is just referring to how organized um, the Nazis were, and for example, they organized their documents. So sometimes context is missed with this model. Another issue with it is that it's a closed loop system, so users can actually try to evade detection with the use of sarcasm or images, and these images can have the text inscribed into it, which would mean that another system has to be implemented to be able to grab the text from these images. So in conclusion, for sentiment analysis, uh, the results show that logistic regression with TF-IDF was the best approach, with an accuracy of 89% and recall of 84%. So that means this system is viable for hate speech detection, but it still has room for improvement. So with this room for improvement, more research is needed for this problem to be able to iron this out and get the best system possible.
Conclusion. To conclude, hate speech, fake news, and sentiment is continuously changing. As time continues to move on, words, phrases, issues, and big stories will change as well, furthering the importance for detection to change alongside society. With different regions, languages, and people in general, it just adds to the complexity of which detection must be formatted. In the future, hopefully machine learning and AI can learn and adapt to language to bring about a smoother transition to the ever-changing world around us and in social media. References. Thank you for watching.